In this video, I will analyze the syllabus, give you strategies and explain using the November 2020 paper 2. Analytical geometry in grade 11, which this question is all about, covers several important topics that are indeed foundational and can help you score well in exams. Here is a breakdown of some key concepts you need to be able to answer in this question. Gradient, perpendicular lines, how to find the equation of a straight line, the distance formula, inclination, area. This question counts 21 out of the 150 and equates to 14% of the paper. These concepts are indeed manageable, and with practice you can develop a solid understanding and proficiency in solving problems. Now this is the question. I suggest you take time and you read through the information and make sure that you relate the words, the information to the sketch. And then in the end, the questions 3.1, they want the gradient. Number 2, we need to show that the lines are perpendicular. Number 3, they wanted coordinates for S. They want the length of WR. They want the size of an angle, and then the area, I think, down here. Now, let's go to the question and let me explain. Triangle TSK is drawn. The equation of ST is y is half x plus 6 and ST cuts the x-axis at M. W -4 lies on ST and R lies on SK such that WR is parallel to the y-axis. WK cuts the x-axis at V and the y-axis at P, 0, -4. KS produced cuts the x-axis at N. TSK is equal to theta. 3.1. Calculate the gradient of WP. So we find WP there, and we are going to use the gradient formula. And then on W, we have the point -4, 4, and on P, we have the point 0, -4, consisting of an X and a Y, X and a Y. And my advice to you is when you substitute, use plenty of brackets, and then we find that the gradient of WP is -2. So where's the marks? Substitution into the correct formula and gradient. 3.2. Show that WP is perpendicular to ST. So what we need is that the gradient of WP times the gradient of ST must give you -1. Then we know that they are perpendicular. So WP's gradient we just calculated was -2, and then ST's gradient was given that it's a half. And then when you multiply those two, you get -1 indeed. And therefore, ST is perpendicular to WP. And then where's the marks? The fact that you knew you had to multiply the two and that the answer is -1, resulting in the two lines being perpendicular. 3.3. If the equation of SK is given as 5y plus 2x plus 60 equals 0, calculate the coordinates of S. Now, what is happening at S is you can see that that's the place where line SK and line ST intersects, and therefore we are going to do simultaneous equations. So there we've got line ST's equation y is half a x plus 6, and you label that one number 1. And then the other one, sk, that was given to you, you label that one number 2. And then what you're going to do, you are going to substitute number 1 into number 2. And that means everywhere, or well, actually just there where you see y, you're going to substitute half x plus 6. And there I did it for you. In y's place, I substituted half x plus 6. Then in the next step, I'm going to multiply out that 5 into both, and then I'm going to add the 30 and the 60 together to form 90. And then what I'm going to do is this 2 under the line, I'm going to get rid of that by multiplying right through by 2. Even this one there, multiply by 2, and then the 2's will cancel, and I'm left with just 5x plus 180 plus 4x. Then you add your like terms. 5x plus 4x is 9x plus 180. Now I'm going to solve for x. So up there, I continued there. I took the 180 across to the right-hand side, and it's minus 180. Then I'm going to divide right through by 9, and I end with x is equal to minus 20. That's the x coordinate there by s. Then to get the corresponding y coordinate, I'm going to take x is negative 20 and substitute into number 1. You can also substitute it into number 2, but it's just a little bit easier. It looks easy to me. So into x's place there, this used to be y is half x plus 6. So there in x's place, I substituted negative 20, and I get y is negative 4. And then the final answer, because the question said give the coordinates of s there, minus 20, minus 4. And then where's the marks for substitution? And then for your x value, there where you got your x value, and then your substitution to get your y value, and then your y value, 4 marks. 3.4, calculate the length of WR. So what is happening there on WR is you find that at R, the x coordinate is negative 4. In other words, there, the x there is negative 4. And then you know this length already. This is the y coordinate, which is 4. So your problem is this length over there. And what you have to do is, since you know that the x is negative 4, you take negative 4 and you're going to substitute it into SK's equation. There, you've got SK's equation, which is 5y plus 2x plus 60. So in x's place, I'm going to substitute the negative 4. And then when I multiply 2 times negative 4, I get negative 8. And then negative 8 plus 60 is 52. And now I'm going to solve y. So the 52 goes across, becomes negative 52. I divide with 5 to get only y, divide with 5, divide by 5. And therefore, my y is negative 10,4. So that means it's this y coordinate is negative 10,4. But since it's distance, it's positive 10,4. And then I already know this distance is 4. So I'm going to add the 2. So WR is 4 plus 10,4, which is 14,4 units. And then where's the marks? The marks are for the substitution into the equation, for the corresponding y value, and then for adding the 2 and to see where you saw that that is 4 units, and then your final answer. 3.5. Calculate the size of theta. Now, there's a process going on here. Let's start. First of all, it's important to realize that we can find the size of beta up there. But in order for us to do that, we will look at SK's equation. SK's equation was given 5y plus 2x plus 60 is equal to 0. And then when we get that one in standard form, that means I took everything across to the right hand side and I divided by 5. I get the gradient of SK, and the gradient is negative 2 over 5, because this number in front of x, that one, that is what gives you the gradient. Now for now, we're going to just ignore the negative and we are going to use m is tan, let's call it beta then if you want, to work out what the angle there is. And then, oh, it's there. Then you, in m's place, the gradient, you only substitute the positive 2 over 5. And your steps with your calculator is second function tan 2 over 5. And you get something that we call a reference angle, which is 21,8. And that means it's this little angle there, 21,8 degrees. And then if you want angle beta, you're going to say 180 minus 21,8 is 158,2, because it's that angle. It's angles on a straight line. So 158,2 degrees. That is what beta is. We're halfway there. Now, we go to ST, and ST's gradient is a half. And then again, we're going to use m is tan theta. So we're going to say second function tan half equals, and we get that angle TMV. Angle TMV is that angle over there, this one. And this is now 26,6 degrees. Then we can say that NMS is that angle over there, is also 26,6, and the reason is because they are vertically opposite. Let me just write the 6 there, 26,6. Now we can work out that little angle there at N. We call that angle MNS. Angle MNS. It's this angle over there. And we calculate that one by saying angles on a straight line. So we subtract B there, and we get that tiny little angle there is then 21,8 degrees. So you can either do it with angles on a line, or you can do it with vertically opposite. It doesn't matter. It's that little yellow one, 21,8. And then now we can work out what theta is. Theta is the exterior angle of triangle NMS. So we can say that theta is then 21,8 plus 26,6, which is 48,4 degrees. And your reason is the exterior angle of a triangle is equal to the sum of the opposite interior angles. And then where's the marks? The marks are there with the gradient of SK, and then the size of beta, and then this 26 degrees that you found there, and then also that you found the exterior angle theta there is 48,4 degrees, and the reason you used. 6. Let L be a point in the third quadrant such that S, W, R, L, in that order, forms a parallelogram. Calculate the area of S, W, R, L. So what we're going to do is we're going to work out the area of triangle SWR. And into the distance formula, we're going to work out the length of SW. But what we need is the coordinate for S is -20 and -4. Remember, we calculated that one. And then into the distance formula, SW's length is 17,89 units. Then we're going to work out the length of SR, and R's coordinate down here was -4 and -10,4. So into the distance formula, and SR's length is 17,23 units. Then we can use the sine rule to work out the area of triangle WSR. And in the previous sum, remember we worked out the size of theta, and theta was 48,4 degrees. So remember, if you want to use the area rule, it has to be two sides and an included angle. So it's half times SW times SR sine theta, the area rule. You slot in the values and you get the area of that triangle WSR is 115,25. But they want the length of the area of SWRL, the big thing, so it's two triangles. So you times it with 2 and you get the area of the parallelogram 230,5. And then where's the marks? The marks are the length of SW, the length of SR, substitution into the area rule, and final answer.
In the next video, I will elaborate more on analytical geometry. Click on the video in the left-hand corner to take you straight to the next question.